Hello, this is Paul from Foresight Tech. In this video, we are going to deal with the separable differential equation, which is the simplest type among all types of differential equations. Let's see the material. First, I will introduce a method we can use to solve the separable equation. Then we will practice two questions together about how to use the method. Here is a summary. So let's see. First, what is a differential equation? We already know, right? And we have an equation. In the equation, we have a differential, or we have a derivative. Okay, so can we see we have the first order derivative. So this is a first order differential equation. We don't know why, right? However, we have an equation, and then we try to solve the equation for the function what is y. And why this we call the separable, because can you see the derivative of y on the right side? And this function we can separate the x and the y completely, right? So this type of equation we call the separable differential equation. And this is the simplest type of equation, is easy to solve. And we list the 4 steps here. The first step is just separate the variables. Okay, how to separate the variable? So we can, so we look at the left. We're going to times dx to both of the sides. And the dy dx is a Leibniz notation for derivative, right? And we also have a way to see the derivative is just a ratio of a differential. dy is a quantity, differential of y, differential over differential of x. So we can times dx both sides. Okay, so dx goes to right. And then for fy, we are going to divide it by fy both sides. Therefore, fy goes to the left. Can you see we have this equation now? So the second step, just integrate both sides of this equation. Okay, integrate, which means to find the entire derivative, right? Integrate the left, integrate the right. This is indefinite integrals. Okay, so we have 2. Now, the third step, we're going to evaluate the integrals. We have 1 integral, 2 integrals to evaluate. After evaluate, we get another equation, right? Another equation, we do not have a derivative, which means a symbol. Okay, we can just resolve for y from that simple equation. Or if we cannot resolve for y, we just keep that implicit equation there for x to tell the relationship between x and y. So here is the method, okay, for separable differential equation. How to use these 4 steps? Let's going to practice 2 questions. Okay, so here is the first question. And what do we do? We need to do 4 steps, right? Okay, so first let's see, is this a separable equation? Yes. Okay, first order, and we can separate the derivative x and the y completely, right? So good, belongs to this type. So what do we do? The first step, we need to separate, all right? Rewrite the equation. Let me rewrite the equation in this way. We're going to separate. Going to separate the x and the y. Okay, separate the variables. It's easy to do, right? We times dx to both sides. In this equation, we times dx both sides and then divide it by y squared. Okay, divided both sides by y squared. So what do we get? We will get this. The left should be dy, not dy dx. So we times dx, so now the denominator goes to y squared. We put the y's together, right? So the right should be 3x squared times dx. Okay, so did the first step. We already separate the x and the y. And then the second step is to what? Integral, to find the antiderivative. So we're going to integrate both sides, right? We're going to integrate both sides. Okay, now we get a definite integral to the left, which is this y squared. We also get another indefinite integral to the right, which is this. Okay, now what do we do? The third step we're going to evaluate is easy. Okay, we're just going to evaluate both the integral. Okay, and now, so how about the left sides? Okay, we can see 1 over y squared. We do have a function, okay, which is a reciprocal function. Do you remember reciprocal function take a derivative goes to negative 1 over y squared? Therefore, we have a negative reciprocal to the left. So it's a negative 1 over y to the left. And then the right, of course, it's easy to evaluate. This is a power function. So we do have another power function as antiderivative, which is x raised to the third power, right? And don't forget plus c. See, this is the third step. And then what do? We just resolve. This is already another equation. Do we have a derivative? No, we do not have derivative. Much simple. Okay, this is a normal equation. So we solve equation for y, the last step. So we do this. We solve for y. Okay, and see what do we get. We will get this. We will get y equals negative, right? Flip. Okay, this kind of fraction we get is a fraction. So which is 1 over x third power plus c. Negative at the beginning. Okay, see, this is the answer. For the first questions, of course, so you realize we have a constant number. This constant number could be any real number. Therefore, we have a series of functions for the solution. Usually, we call this is a general solution. Okay, a general solutions. Okay. Let me go over again. 4-step symbol. Okay, separate, integral, evaluate the integrals, solve for y. Now, let's work on another one question. Okay. Now here is the second question. Well, look at it. It's still the same equation, differential equation. However, these questions we have one more. Given condition. What does it mean? Do you remember the first questions when we solved? We have a constant number c, which is a series of functions, right? Now, in these questions, we need to find the solution based on the initial condition, which means what? Initial condition is here. Y, which means the function of y at x equals 0 equals 1. When x equals 0, y equals 1. See, this is another information. We can use this information to solve for c. Therefore, we finally get a specific solution. Okay. Let me write here. And this type of equation, usually we have a name. We call this. We call the initial value problem. Okay, so let me write here. And usually this type of equation problem we call the initial value problem. Especially is important problems in physics. Okay. Let me how to do these type of questions. Of course, the first type I'm going to show you again. Okay, repeat all the steps. We're going to get a general solution. We have a constant number c. The second step, we are going to use the initial condition to solve the constant number c. Okay, to get a specific solution. Now, the first one, so we have 4 steps, right? Separate the first. Okay, so I'm going to separate which is dy dx. No, sorry, we times dx both sides, and then divided by y squared both sides. So I will get this. So that 3x squared dx, right? And the second integral both sides. So here is the integral for the left. Okay, so I will get a y square, put it to the denominator. I integrated the right side, which is this, right? And then we solve. Okay, we evaluate both. So the left is a negative 1 over y. The right is x raised to the third power of y. And then don't forget the c. And the last step, we solve for y, right? If I solve for y, I will get this. We do have a negative. Don't miss the negative. Okay, it's 1 over x third power plus c. This is exactly the same as the first questions we did. Okay, what kind of solution we get? We have a name. Usually we call the general solutions. Okay, it's not only one. We have a lot of. Okay, now what do? We need to use here is the initial condition. Okay, we need to use the initial condition to solve for the constant number c to get a specific solution. How to do? All we need is a plug x equals 0 to here, and then we will get y equals 1, right? Let me draw the equation. When we solve, is this negative 1 over, sorry, is negative 1 over what? When we plug 0, which is 0 raised to the third power is 0, and plus c. This is y, right? Y equals 1. Can you see this is a simple equation? I will solve this equation. Of course, we will get c equals negative 1, right? So we will get c equals negative 1. Therefore, if we plug c negative 1 into the general solution, see what do we get? We will get a specific solution. So we finally have y equals this negative a fraction, right? Is this kind of fraction 1 over x third power plus c plus negative 1, which is minus 1. Here is the specific solution for this type of initial value problem. Okay, that's all for this topic. Thank you. If you have questions about this topic, please leave your comment. If you like this video, please give me a thumbs up. And you are very welcome to subscribe to my channel for more videos. Thank you for your support. In the next video, let's see. We are going to deal with the first order linear differential equation, which is a simple and well-studied type of differential equations. Hope to see you there. Thank you. Have a nice day. Bye.